In the flat earth bottle, it is an electrostatic downward acceleration vector, right? That keeps us on the ground, but it is only in this realm. It's only in this realm, which has a flat base and a flat top, if you will, which acts as the firmament. There is a charge potential that is applied to the ground, earth ground, and the firmament, and we know that it's there. We can measure it at 100 volts per meter. It's been measured all the way up to 50 kilometers and more, I'm sure, which of course is 5 million volts. And if we're accurate about our, estimate of the firmament ceiling being at about 100 kilometers, which is about 62 miles, then we're talking about 10 million volts of electrostatic potential, which we see reflected in things like lightning strikes, sprites, elves, other types of electrical discharges, things that actually we can prove and replicate with plasma physics right here in any lab, right? It doesn't require us making up complete backwards nonsense physics. We can actually test it and replicate it and make models of it and say, look, isn't this amazing how this works, right? We don't have to come up with all this theoretical nonsense and try and twist your head off to get you to accept this position.
This is absolute rubbish. Electrostatics deals with objects with an electric charge. The idea that objects move down because they are charged can easily be disproven by connecting a thin wire to the object and attaching it to the ground, without impeding its fall. This would discharge any electric charge it had. Thus, according to this opinion, it's not even worthy of calling it an hypothesis. It would no longer fall. If everything had an electrostatic charge, we would see discharges all over the place, not just when you create a static charge by rubbing a balloon. There are so many experiments that can disprove the idea that it's electrostatics that cause objects to fall. 100 volts per meter. Even if that is true, which I doubt, so what? Power is measured in amperes. You can generate thousands of volts of electricity by rubbing a balloon on your hair.
Okay, Malcolm. Do you agree that the atmosphere is electrically charged?
No. Only on rare occasions.
Okay. How about you, Theodore?
Yes, there is an electric potential on the column of air we call the atmosphere.
The whole 100 volts per meter claim actually comes from Caltech. Theodore, do you agree with it?
Yes, I have no reason to doubt them.
Fantastic. How about you, Ben?
E field in the atmosphere is around 100 volts per meter.
Do you agree that that is not a rare thing?
Sure, I agree it's not a rare thing.
Hi gang! I'd previously demonstrated generating power using atmospheric electricity. A hexacopter was used to lift one end of a wire high up into the air. Meanwhile, the other end of the wire was connected to a corona motor near the ground. Electricity then flowed through the wire and corona motor, making it turn.
Okay, Malcolm. Do you claim that was a rare occasion, or do you claim it was faked?
Yes, it is fake. His excuse as to why we don't get a discharge from standing on the ground is your body is a good enough electrical conductor that standing on the ground, you are basically part of the ground and you don't see a problem with that. He doesn't give a reference we can look up to see the Feynman lecture he adapts. His diagram of the top of the wire that is supposed to collect the electricity is nothing like the top of the wire in his experiment, which is a thin wire attached to a drone. This is very suspect.
This is a digital version of the Feynman lecture from Caltech University that he was referring to.
Much of the following explanation is adapted from Nobel Prize-winning physicist Richard Feynman's lecture on physics, his section called Electricity in the Atmosphere.
He showed you the name of the person giving the lecture, he showed you the book, he opened the book and showed you the pages. I even provided a digital link to where you can read the lecture for free online. Yet you claim he didn't provide a reference?
I do not believe what he says about electrostatic motors needing a very small voltage. An electrostatic motor is based on the attraction and repulsion of electric charge. Usually, electrostatic motors are the dual of conventional coil-based motors. They typically require a high voltage power supply, although very small motors employ lower voltages. He tells us that the electricity in the atmosphere is in the order or microamps, that is barely enough to turn his motor. In reality, the charge in the atmosphere is just 10 picoamps per square meter. You would need a very large collector to collect just a few amps, not a point at the end of a wire. Bottom line is that there is not enough electricity in the atmosphere to be economically useful. The idea that this almost negligible amount of electricity could be responsible for gravitational attraction is absurd.
Okay, let's take a look at your video there.
Our atmosphere is teeming with electricity, even when we have fair weather conditions.
Our atmosphere is teeming with electricity. That was the very first thing he said in the video. Yet you told me, no, it's only charged on rare occasions.
Even when we have fair weather conditions. And historically, there has been great interest in tapping this resource. When Benjamin Franklin conducted his famous experiment, it was a monumental feat that developed our understanding of electricity. This interest in tapping atmospheric electricity continued through Cavallo and later Nikola Tesla. And over time, there have been numerous attempts at doing so. Some of them have been very successful. It must be understood that even if we collect electrons with a potential difference of 100,000 volts, but the current is merely 20 picoamps, then the total power we will capture is just 2 microwatts. So the charge collection rate also has to be improved.
Okay, this is where you're getting the picoamps from, but he's not saying that is the only amount you can ever get from the atmosphere. He's saying it depends on your apparatus, the thing that you're using to collect the energy from the atmosphere.
For example, as early as 1925, the Estonian inventor Hermann Plossen built on Tesla's idea of wheelwork of nature. In fact, Plossen claimed to have obtained power in the order of kilowatts through his apparatus, from 0.72 kilowatts to 3.4 kilowatts to be precise.
That's a lot more than just a few microwatts, buddy. Did you even watch your entire video? Now here's a video from National Geographic that describes how some spiders are able to use electrostatics in order to fly.
But even under normal weather conditions, electricity is all around us.
It's not just a rare thing.
The atmosphere holds a positive electric charge, while Earth's surface holds a negative charge. Just like with magnets, similar charges repel away from each other, and opposite charges attract. This interaction creates something called an electric field. The force of this electric field is what allows for some spiders to defy gravity in a remarkable behavior called ballooning.
Malcolm, do you agree that some spiders are able to fly because of the atmosphere's electric charge? Or do you claim that National Geographic lied about this?
But spiders are very, very light. Apparently there is an electric charge in the atmosphere.
All right, Malcolm, this is rocket-triggered lightning from the University of Florida. Here they are attaching a wire to a rocket and sending it up, and then they watch the wire explode. Malcolm, do you agree that the wire exploded because of the atmosphere's high electric charge? Malcolm has chosen not to answer. Here's our ladder so far. We've got a foundation. Now perhaps if we can fill in a few more rungs with common ground, you'll come to agree with me that things fall because of electrostatics. Hang in there, guys. Thank you all for watching.